So XIAO family got two new and really powerful members called as XIAO NRF54L15 and XIAO NRF54L15 Well, these two boards are based on Nordic chipset which got some really promising configurations, and the coolest part, this uses the Zephyr RTOS, which is one of the most popular and most widely used real-time operating system in the market. And this video covers everything that you need to know to get started with this board, starting with the unboxing, the specifications. Later we'll discuss what is Zephyr RTOS, and further we'll start with setting up the tools required for Zephyr RTOS both for Windows and Mac system. And finally, we'll be testing out a couple of example codes in it, so by end of the video, you'll be comfortable enough to use this board and make your own wireless projects. And in case if you make it till the end, you'll also get a chance to participate in a giveaway in which you can get these boards for absolutely free. And now, let's just grab those hardware and let's start with the unboxing part. So this is how you'll receive the board, and yes, Seeed changed the packaging of almost all the XIAO boards, and now you'll receive them in this plastic box. So inside the box we get to see the main XIAO board, and below that we get to see some mail headers and a QR code, which is not a sticker by the way, and scanning to which lands you on a XIAO series page on Seed's website. And the unboxing experience is same for both the variants. So yeah, that's all you get inside the box, and now let's move ahead and discuss the specifications of the board. So as we know, this XIAO board is based on NRF54L15 chipset which got ARM Cortex M33 processor clocked at 128 MHz, and along with that it also got a RISC-V based coprocessor. Now talking about the memory, then it got built-in 1.5 MB of non-volatile memory, or we can say flash, 256 KB of RAM, and if I talk about the wireless protocols, then it supports a lot of them including Amazon Sidewalk. Plus, it also supports Bluetooth channel sounding, which is one of the features of BLE6 which is used for proximity detection with great precision. Along with that, this XIAO board also got a built-in ceramic antenna and built-in battery charging circuit in it. And now talking about the sensors, then the normal version don't have any built-in sensor, while the Sense version got built-in 6-axis IMU and a digital microphone on board. And all this in the same XIAO form factor of just 21 by 17.5 mm. So that was all about the specifications of this board, and now it's time to move ahead and learn how to use it. Now this board currently doesn't support Arduino IDE as of now in August 2025, but we may get its support in near future. So as of now we can use this board only with the help of Zephyr RTOS. So for those who don't know, Zephyr RTOS is a small, scalable and open source real-time operating system designed for resource-constrained embedded devices. Means you can think of Zephyr as a Linux but just for microcontrollers with less RAM, less storage and less powerful. So now the question is, we do have a couple of other RTOS in the market, so why Zephyr? Well, there are a couple of reasons for it, like Zephyr is completely open source and it's backed by Linux Foundation. Secondly, it supports the boards from multiple manufacturers, so you can run Zephyr on your Arduino boards, ESP boards and also on the Nordic semiconductor boards. Further, Zephyr has a huge community worldwide, so getting a help with your code will be really easy, and the most important part, Zephyr RTOS is not just for building projects, but you can make commercial grade products as well. Like on the screen you can see a couple of products built out of Zephyr RTOS. So because of these features, Zephyr is becoming more and more popular RTOS in the market. So that was basic overview about what Zephyr RTOS actually is. And now let's move on to our computer and let's see what are the necessary softwares and packages required to write our first ever code in Zephyr RTOS. So before uploading the code, we first need to set up the Visual Studio Code in our computer. So for that, you first need to download the Visual Studio Code for your operating system. In my case, I have downloaded one for the Mac, so let me just open that up. So in the Visual Studio, you need to go to the extensions and here just search for NRF. And you need to install this extension called as NRF Connect for VS Code extension pack. Just click on it and here you will find the install button. In my case, as I already installed it, so it's not showing up. And once you install it successfully, a new option of NRF Connect will appear here. So just click on it after that. Later, after installing the NRF Connect, you need to install the toolchains. For that, you can go to Manage Toolchains click on install toolchains, and here you need to install the version 3.0.1 which is recommended by the Seeed team itself. Again, in my case I have already installed the 3.0.1, hence it is not showing up, but in your case you have to click on 3.0.1 and just press enter. It will install and it will definitely take some time, so that's why I did all the steps before. After installing the toolchain, as you can see I'm already having the 3.0.1 here. Okay, so after installing the toolchain you need to install the SDK. For that, click on manage SDKs. Again, install SDK, and you need to install that same 3.0.1 SDK version, which is this. Again, in my case I have already installed. You just have to click here, press enter, and it will get installed, and definitely will take some time. Okay, so now we are good to go to open up the first example code. For that, you can click on create new application and click on copy a sample. Now here you can just type as blink and it will say blinky sample. Just click on it. So later after that, you need to remember this particular location where your application is being created. In my case, it is inside users /Sachin Sony /blinky. So we'll need this location later on. So just remember where you are creating this application, and let us just press enter. Click on open. It will open up the example code here. Okay, so as you can see, the blinky appeared here. So now here we need to do one more step, which is to add the support for XIAO board, and for that you can refer to the documentation page from the Seeed, whose link I'll be attaching in the description. And here under point number 5, you have an option called as download the libraries. Just click on it and it will open up the GitHub repository. Okay, you just need to download the zip file of GitHub repository, and after downloading, when you open that repo, you will find a folder called as Zephyr. Go inside that, and here is a folder called as board, which has the XIAO board support. So just copy this folder, and now you need to go to the folder where the blinky application was created. In my case, it's inside Sachin Sony, so I'll go inside it, and here I will just paste that boards folder and I will replace it with the existing one. And with this, we now have the support for the XIAO board in the Visual Studio. Okay, so now we are good to go to build this application and upload it into our XIAO board. So for that, what you can do is you just need to go to this NRF Connect application, or the option we can say, and below that you'll find an option called as application and blinky, and here is the option called as add build configuration. Just click on it, and here under the board target just type as XIAO, and you'll find an option called as XIAO NRF54L15. If you don't find this, I'll recommend you to close this Visual Studio, open it once again, and later you can find it. Okay, so I'll click this board option, and that's pretty much it. You just need to click on generate and build, and it will generate the firmware file which later need to be uploaded onto our board. So this will definitely take some time, and in the meantime we need to do one more step, which is the last step, which will help us to upload this code into our board. So let me show you how to perform that step. So for that, we'll again go to this Seeed Studio's documentation page, and this particular step, which is the last step, has different ways or different processes for Windows and macOS. So I'll let you know for both the system. As of now, I'll show you for the macOS. So I'll click on Mac, and here are a couple of commands to be performed. So let me just open up the terminal window. So first command is this. So I'll copy it and paste it here, press enter. I need to put the password and press enter. Again, press enter. Okay, so this command is executed successfully. Let's go ahead and download or copy this command and paste it here, press enter. This is also done. Now this one, copy and paste here. Perfect. And now after installing, we just need to type this command to see if it is installed or not. And yeah, it is installed. So I think we are done with all the steps for the Mac OS. And now let me just show you how to upload this code, and later I'll show you the steps to be performed in the Windows system as well. Okay, so after doing this, we'll go back to the Visual Studio Code, and here as you can see, we got the build folder under Blinky. That means the application is successfully built. Now what we need to do is we need to go to manage tool chains, and here click on open terminal profile. It will open up a terminal window here, and here we just need to type the command as vest space flash. Now make sure the XIAO board is connected with a computer, and after that just type enter, and let's wait. And yes, the code is successfully uploaded, and on the XIAO board we can see the green LED, the onboard LED blinking at the interval of 1 second. That's the very basic, very first blink example code that we uploaded with the help of Zephyr RTOS using Visual Studio. So that was the step for the Mac OS, and now let me show you the steps for Windows OS. Okay, so now let's see the steps for the Windows OS. So first of all, we need to open up the PowerShell. So I'll press the Windows button and type PowerShell, and here's Windows PowerShell, and we need to run as administrator. So we'll click on it. Perfect. So in this terminal, we need to first type get execution policy. So I'll copy it and paste it here. Press enter. Okay, let's type this one. It's not mentioned like what response should we get here, but anyways we executed both the commands, and now let's just type this command. I'll copy it and we'll paste it here, and let's see what happens. Okay, this says it already detected this chocolate in my system, but I don't think I have installed it, so I have deleted that folder, and I'll try to paste that line once again, and let's see if this works or not. Okay, so it started downloading and installing it. Okay, so we are done with this. Now let's move on to the next step, which is this. So I'll copy, go inside the PowerShell and paste it here, and let's press enter. I'll press Y. Okay, so this step is also successfully done, and now I think we are done with everything. We just need to confirm our installation. So I'll just copy this command and paste it inside the PowerShell, and yeah, it detected, so everything is installed successfully. Now we are good to go to flash the code using the Windows OS. For that, again we'll need to go to VS Code. Let's open that up, and here into manage tool chains, and then into, let me just confirm, into open terminal profile. So yeah, here is the terminal window, and now here just we need to type as west flash. Make sure the board is connected with the computer. In my case it's already connected, and let's just press enter. And yes, the code is successfully uploaded with the Windows OS as well, and on the board I can see the green LED blinking at the interval of 1 second. So those were the steps for both Windows and Mac OS to flash the firmware in the XIAO board, and now let me show you a couple of other example codes and how we can flash in it and how to test them out. So first of all, like previously we tested the LED blink, and now let's just test out how to read the button data, and based on the buttons data, how to control the LED. For that, what I'll do, I'll just go to Visual Studio and click on File and Open Folder. Now in my case, I already created the folders of 3 example codes, and I'll show you those 3 example codes only. Also, I'll be providing all these folders into my GitHub repository so you can try it out. Now, this folder not only contains the code file and all the configuration file, but also I have added the XIAO board inside the boards folder, so you don't need to do that step as well. Okay, so let's start with the buttons folder. So I'll click on this folder and click on select folder. It will open it up in the Visual Studio. Now if you want to visualize the code and the logic, well, you can find that under main.c. So inside the source folder there is a file called as main.c, and the main.c contains all the main logic of that particular code. Okay, so this structure may find a little different from the one which we have seen in Arduino IDE. Well, there are a couple of more steps to be performed here, but yeah, we need to get comfortable with this if we want to make some production ready code. Okay, so yeah, if we go inside the main loop, which is nothing but the while one, similar to the void loop, we can see that we are just reading the button state. So if the button state is 0, that means if the button is pressed, we are just turning on the LED, and if the button is not pressed, then we are turning the LED off. And this will repeat after 10 milliseconds of delay. We can change the delay as much as we want. Okay, so now what you need to do after opening up this code, you need to go to this NRF Connect, and here you can see the code is already built, but we need to remove this build configuration and need to build it once again to flash successfully onto our board. So after removing this, click on add build configuration, and as we have already added the XIAO board, as you can see, the XIAO board automatically appeared here. If it doesn't appear, make sure you do the board step that we done in the blink example code, then it will appear. After that, you just need to click on generate and build, and this will definitely take some time to build the firmware file. So let me just fast forward this video. Okay, so it successfully built the folder. Now to flash it, we just need to go to manage toolchains and click on open terminal profile. And here, first of all, make sure the board is connected with the computer. And after that, you just need to type out west space flash, and this will successfully flash the firmware into our board, and it's successfully flashed as well. And now if I show you the working of it in my smartphone's camera, let me just turn on the video recording. And here if I press this push button, as you can see, the green LED on board gets turned on, and if I release it, it gets turned off. Press to turn it on and release to turn it off. On, off, on, off. So yeah, that's how you can read the button status and can give the output to dedicated GPIO pin. So that was another example code which I tested in the XIAO board. Now let's try out other two example codes. So I'll click on close folder to close it, and now I'll again go to files and go click on open folder, and this time let us test out the example code called as DMic or digital microphone. Select the folder. So I'll be testing it in the XIAO Sense board only. This will not work in the regular NRF54L15 board. So after that, again, if you want to check out the code, you can go to source and main.c file, and this contains the complete logic of this code. Okay, and after you are done with your .c file, you can go to the NRF Connect, then remove this build configuration. Okay, so after removing this, click on add build configuration, and here make sure the board selected is of XIAO. Yes, it's selected, and just click on generate and build. This will build the firmware file ready to be flashed onto our board. Now in the meantime, if I take you to the main.c file, so now what this code does is it is recording our audio for I think 1000 milliseconds, yes, 1 second, and it is storing inside a buffer. Okay, let me show you that buffer. Okay, so we are storing it inside the buffer, and there's no such logic written here to retrieve that buffer and to listen to that audio. We are just recording it and storing it, and it will just say exiting after the 1 second timeout period. So let me just show you the result. Okay, so the build is successfully done. So we can go to NRF Connect, into manage tool chains, then into open terminal profile. Make sure the board is connected and just type out west space flash, press enter, and this will flash the code into our XIAO board. Is successfully flashed. It's pretty fast. Then we can go to serial monitor option, and here just select the right COM port which is selected already and click on start monitoring. Hello. Okay, let's just try to reset the board. Hello, hello, hello. And yeah, as you can see, it says it has successfully recorded and stored inside the buffer all the audio data, and lastly it says exiting. So this is kind of confusing. Like, it is definitely recording the data, but I'm unable to listen to what kind of data it's been recorded. Okay, I didn't found it. If you know how to listen to this particular, like how to retrieve the buffer, how to listen to the audio, well, if you know, let me know in the comments, because I didn't find that particular option. But yeah, that was another example code that we tested and successfully running as well. And the last code is of the IMU data, that means the accelerometer and the gyroscope data. So yes, the Sense board do have the built-in accelerometer and gyroscope. So click on open folder and go to desktop, and the third one is named as untitled, but anyways, this is for the IMU testing. If you go inside the source and main.c file, oh, there are two main.c, yeah, so this is the one. Okay, so inside this we are giving the I2C address of that IMU chip. Okay, so it's working on I2C, and basically inside the main loop, what we are doing it, let me just show you. So yeah, inside the while one, inside the void loop, we can see we are just displaying the raw data, that means the data of gyroscope and the accelerometer after an interval of 1000 millisecond, or we can say 1 second. So again, we'll go to NRF Connect and we'll remove this build configuration. Click on add build configuration, and here make sure the XIAO board is selected. Yes, it is selected. Now we can click on generate and build, and this will build the firmware file ready to be flashed. And in the meantime, we can have a look over the main.c file as well. Let's just go once again. This is the one. So I was saying that it is printing the raw data after interval of every 1 second, and for that this function is being called. So if I go to the definition of this function, and here it is, and as you can see, using the printf function, which is similar to the serial print, you can see we are displaying the accelerometer's raw data like the XYZ axis, and later we are displaying the gyro raw data again XYZ, and in the end we are printing the trigger counter, I guess. Yes, let me just see. Yes, we are increasing the counter at the start of each loop, so we are printing the counter value as well. So these 3 data points we are printing on the serial monitor, and yeah, let's wait for the code to get built and we'll test it out in the serial monitor itself. Okay, so code is successfully built and we can go to NRF Connect and later go to Manage Tool Chains and click on Open Terminal Profile. Make sure the board is connected, and after that just type out west space flash, press enter, and this will flash the code, and yes, it's successfully flashed. So we can go to the serial monitor, click the right COM port, click on Start Monitoring, and yeah, as you can see, trigger counter 6, 7, 8, and we are getting the raw data of accelerometer and gyroscope. So if I do some movements, the values are being changed. If I keep it steady, the values will stay more or less the same. It won't have much difference. But if I change it, yeah, it is definitely having a lot of difference. So yeah, that was a built-in sensor testing as well. And these were the 3 example codes which I chosen to test out in this particular video, but you can try out all of the example codes as well. Let me show you the GitHub repository from the Seeed. So here's the GitHub repository from the Seeed, and here as you can see they have a couple of example codes for Blink and Bluetooth and DMIC recorder, that's the digital microphone recorder. I tried this, but it didn't work on my end. You can try it out. Then the DMic, which we have tried. Then we also tried the ePaper one. I haven't shown in this video, but I already tried it to run the ePaper display using this XIAO board, and it works successfully fine. So that's how you can try different example codes from the Seed's website as well. The steps will be the same which I have shown in the video. The only thing is make sure you add the board's support into the boards folder. That's the only change. Otherwise, everything will be pretty much the same. And yeah, that's how you can easily use the XIAO board running Zephyr RTOS. So those were a couple of example code that we tried on the XIAO board running Zephyr RTOS. And now what I think we do need to have a couple of more example codes to try out complete features of this board, like the one for Zigbee, Thread, Matter, Amazon Sidewalk, and also for Bluetooth channel sounding. So currently we do not have any of these example codes, but I am pretty much sure that Seed's team will definitely work on it, will provide us all this and much more example codes in near future, so that we can explore all the features of this board and can make some amazing projects out of it. Now here one more thing, what I think is writing the code may seem tricky for Zephyr RTOS as compared to writing it in Arduino IDE, but with more and more example codes and more project videos on like Zephyr RTOS topic will make all of us more comfortable on using it, and later we can write our own codes as well that will be production ready. So we all need to definitely work on it. And now let's talk about the giveaway contest. So yes, I am going to give away one XIAO NRF54L15 and one XIAO NRF54L15 cents to 2 of my lucky viewers, and participating in this giveaway contest is really very simple. So first of all, you need to be the subscriber of the channel, and also you need to click the like button of this video and let us comment below your project idea with the help of this board, and later after a week we'll be choosing 2 random lucky winners out of the comment section, and we'll be giving away each of the board to each of them completely free of cost. So yeah, that was all about the video and the giveaway contest. I hope you liked it. I hope you got to learn something new from it. And yeah, that being said, I am just ending this video here and now. Just wait for my next video and then explore, learn, share with me, techiesms.